This video covers feature patterns and topology patterns. Feature pattern and topology pattern both allow you to pattern part features, but their typical usage differs. Feature patterns are typically used with native Libre design features. Topology patterns are used with imported parts where there is no design history. Common between both: linear pattern, linear path, spacing, number of copies. Circular pattern, angle and center. Differences: feature pattern. You select the features that you want to pattern. The pattern can extend anywhere. Topology pattern. You select seed faces that you want to pattern. The pattern cannot extend outside of the original geometry. Feature patterns create copies of a feature by repeating it in a linear or circular array. You can use a linear pattern to repeat a feature in one or two linear directions. To create a linear pattern, from the Part Modeling ribbon, select Linear Pattern in the Geometry Transform box. The Linear Pattern dialog appears. Select the features to be patterned. Check the Pattern Geometry box if you want to pattern the geometry exactly. You will normally be concerned with this option when you are patterning a feature that has been created using references to existing geometry, as was done here, for example. Here's an image of two different results. The model on the left was done with a Pattern Geometry box checked. On the right is the unchecked version. Select the linear path for the first direction. An axis or edge can be used for the path. In this example, the bottom edge of the block is used. Specify the number of copies, including the original. Specify the spacing between each copy. Click the Change Direction option to create a pattern in the opposite direction on the path. If required, repeat steps 4 through 7 to create the pattern in a second direction as done in this example. Enter a name for the pattern in the Label field if desired. Click OK to create the pattern. To create a circular pattern, from the Part Modeling ribbon, select Circular Pattern in the Geometry Transform box. The Circular Pattern dialog appears. Select the features to be patterned. Specify the number of copies, including the original feature. Select the Included Angle option or the Complete Revolution option. The Included Angle option allows you to enter the incremental angle between the features. The Complete Revolution option assumes you are creating a complete circular pattern of features and calculates the angular spacing for you, 360 degrees divided by the number of copies. If the Included Angle option is selected, in the Angles section, enter the incremental angle that separates each instance, and if necessary, select Change Direction to reverse the direction in which the pattern propagates. Click in the Center entry box and in the Design Explorer work area, select the edge or axis that will be the center of the pattern. Check the Pattern Geometry box if you want to pattern the geometry exactly. This works the same way as this option did in the previous example on linear patterns. Enter a name for the pattern in the Label field if desired, and then click OK to create the pattern. Topology patterns are similar to feature patterns except you do not have a feature to pattern. Topology patterns can be used to make copies of existing geometry, such as faces and edges. They are particularly useful when you're working with an imported model that does not have a feature history. Topology patterns require you to tell a Libre design which faces you want to pattern. You can pattern any set of faces, either a set that would make a complete feature, or a set that represents only part of a feature. In this example, a linear topology pattern will be created using a portion of existing geometry on this part that was imported into a Libre design as an IGES file. We will not go into great depth on the features in the dialog because they are nearly identical to the feature pattern dialog you were introduced to in the feature pattern example. To create a linear topology pattern, from the Part Modeling ribbon, select Linear Topology Pattern in the Geometry Transform box. Select the seed face. Using the seed face, Libre Design will infer a group of related faces adjacent to each other that will be included in the pattern. The inferred faces will be highlighted in the work area, and the number of selected faces will be displayed in the dialog next to the seed face. Complete all the requirements for the first direction. In the linear path, select an edge or axis to determine the direction for the pattern creation. Enter the desired spacing between each copy. Note, the resulting pattern cannot overlap itself. Setting the spacing too low can make the bodies overlap, resulting in an invalid body. Enter the number of copies, including the original. Fill in the information for the second section if necessary, as in this case. Check the Check Results box to have a Libre design detect whether or not the resulting bodies from the pattern are valid. It is a good design practice to leave this box checkmarked. If this box is unchecked, you may inadvertently create a pattern that appears to be valid, but in reality is not. Note, if you do not use the Check Results option, you should go to the Viewing and Analysis ribbon and select Check Part after creating the pattern to verify that your model is a valid body. Click OK to create the pattern. The Circular Topology Pattern feature is similar to the Circular Feature Pattern in function and operates with seed faces like the Linear Topology Pattern feature. This video covered feature patterns and topology patterns. The featured linear pattern and topology pattern features are similar, with the major difference being the type of items that can be patterned. The featured circular pattern and topology circular pattern features are also similar in the way they operate, but different in the same respects as the linear pattern versions. The feature pattern tools are used with standard Libre design features which will be listed in the Design Explorer. The topology pattern tools are generally used with imported models that have no design history associated with them.